So I did not hit record in time to show this type of factoring, but let me know if you have questions if you're watching this video. I just beat myself up about it, so don't do that. Okay. Next is, remember I said there's like 3.5 types that we're going to do? This is like the 1.5. These are called quadratic trinomials, right? Quadratic is degree 2, and there's 1, 2, 3 terms. Degree 2, 1, 2, 3 terms. We have the short method, the long method, okay? We get to use the short whenever there's a 1 in front, okay? These are the long because it has a number other than 1 in front, right? In front of these x squareds is a 1. We love these. These are easier. But we also called them chart problems. So if you remember, we make a chart, just a little baby chart, nothing, and I don't need to see this. This is my method. Let me give you that speech again. I call these chart problems. There's lots and lots of different ways of factoring quadratic trinomials. So if you learned one from another teacher in your past and you like it, you keep using it. I don't need to see a chart on your paper as part of your work, okay? All right, so what we're doing is asking ourselves, we're going to make one column multiplication and one column addition. And what goes in there, if you remember, is whatever A times C is. Remember, a quadratic is in this form. Okay, A times C is what goes in this first spot. So A times C, that's 1 times 5. And what goes underneath the plus sign is whatever your B value is. B is -6. So what we're looking for here is the two numbers that multiply to get 5, but also those same exact numbers add to get -6. So we've got some choices, right? 5 could be 1 times 5 or 2 times 3, but only one set of those is going to work in both columns. So if you remember when I taught this to you before, I call this your workspace. It's fine to make mistakes. Go ahead and make all the mistakes you want. Like if I used 1 times 5, that would be 5, right? But 1 plus 5 doesn't give me 6. How can I make this a -6? Make them both negative. I'm sorry, this is so small. Put a negative in front of each of these. Now, that works, right? -1 plus -5 is -6. But make sure when you make these negative over here that you also get a +5. And you do, right? -1 times -5 is +5. -1 plus -5 is -6. Both columns have to match exactly. You can't have positives and then negatives or one of each and change it and all that stuff. When it's the short type, when there's a 1 in front, we're ready to write our final answer, which is 2 parentheses. We put an x at the front of both of them. That's the x squared, just split into 2 basically. And then the -1 and the -5, we call them negatives over here, whatever, come over into the parentheses. It does not matter if you put -5 first or -1 first. It doesn't matter because this is multiplication. You could check this if you FOILed it, you would get what's above it, okay? So if you were really stressed about, did I get it right, you could FOIL that and check it. All right, let's do the same thing with this one. Make a little chart. What two numbers multiply to get something and add to get something? Those two numbers are 1 times -6, which is -6. And what's our B value? 1. There's a 1 in front of that x. Okay? So we had a 6 over here. Are we going to be using, well, forget that. 6 times 1 gives me 6, but there's no way to add or subtract 6 and 1 and get a 1, right? What else can we multiply to get 6? 2 and 3. So a lot of times, guys, I'll say find the numbers first. 2 and 3, we can multiply to get 6 and subtract to get 1. We just have to play with the signs now. And in this column, listen, in this column, it doesn't matter which one you make negative. It makes no difference. You're going to get a -6. But it does matter over here. Which one of those is going to be negative in order to get a +1? And you can use your calculator. Which one's going to be negative? 2. Negative 2 plus 3 is 1. Now make sure it works over here. Negative 2 times 3 is negative 6. We're ready to write our answer. X minus 2, x plus 3. Any order. As long as the 3 is positive and the 2 is negative, it doesn't matter which one goes first. Okay, we're about to do the hardest type. Yeah, I would wait. I'd rather you wait till we're done with the notes. Yep. This is the worst one. Okay? And oh, so the short, look at the problems. 7, 8, 9, and 10 are the short one. How do we know that it's the shorter method? Because there's a 1 in front of your squared letter. So that is 7 through 10. I'll probably shorten this here in the middle for you. You don't need to do 4 of them, but I'll put the key up so you can see all of them if you want to practice some, but I'll shorten it for you in a minute. All right, how do I know what type of problem this is? It's still a quadratic trinomial. It's in this form, but A is now 4 instead of 1. That's what makes it the longer method. We still start out making our chart. Now, the difference here is A is 4, so it's 4 times negative 15. 4 times negative 15 is negative 60, and our middle number is negative 4. Now, we get bigger numbers like this, we're going to have to pick up our calculator. I don't do these in my head necessarily. There's plenty of these I don't know. So you pick up your calculator and you start trying to find two numbers that multiply and get 60. Don't worry about signs. And add or subtract to get 4. So 60 and 4. So maybe take 60 and divide it by 5. If I divide 60 by 5, I get 12. Well, that's not going to make a 4, whether I add or subtract. 60 divided by 2, right? 30 and 2, there's no way to make a 4 out of that. 60 divided by 6. Oh, 6 and 10. If I subtract 6 and 10, I can get a 4. So I just found my two numbers, okay? So I know I'm going to be using 6 times 10 and 6 plus 10. Now, we all know that 6 times 10 is not positive 60. I mean, negative 60 is positive. And we all know that 6 plus 10 is not negative 4. This is where you play with the signs, though. How do I make a negative 4 with a 6 and a 10? One of them is going to be negative. Which one? I can't fit it. Negative 10. Yeah. 6 plus negative 10 is negative 4. Make sure it works over here. Yep, it does. Here's the long part. Listen to me. These are the ones people get wrong the most because they'll just do exactly what we did up here. They'll write x minus 10 and x plus 6. But when there's a 4 here, we have some extra steps. Notice I left extra room here. This is the longest one. These take 2 seconds. We're almost done, okay? So stay with me. Do not lose interest. Whenever we have the 4 in front, once we find our two numbers, we bring down the outside 2. So we have 4x squared and minus 15. Remember, a sign it's in front of a number stays with it. And then we split the middle. We're splitting the middle into these two right here. If you have a choice, which we do, one of them is negative, we're going to put the negative first. We're also going to give it a variable. Those two numbers in the middle should equal what we split. So negative 4x is negative 10x plus 6x. That is a true statement. We just broke 4x into those, negative 4x into those two numbers. Do you guys remember the next step? Parentheses. Parentheses around the front 2, parentheses around the back 2. And guess what? These are two in one problem, like a bonus, of these. Do the GCF. So the GCF of 4x squared minus 10x is 2x. Whatever's left over goes in parentheses. Now, what's really nice about these problems is that if we do it right, when we do the GCF of this one, our parentheses should be the same. So what does 6 and 15 have in common? 3. Do they have an x in common? Nope. So 3, divide by 3, both of those, we get 2x minus 5. Like I said, if we did it right, these two should always be identical. So you'll know if you made a mistake. And now you're ready to write your answer. That wasn't too bad. Your answer is going to be 2 parentheses. Remember, I call these your identical twins. 2x minus 5 goes in either one. It does not matter which one you put it in. Okay? Either one. Doesn't matter. And then the hearts, 2x plus 3. Our GCFs, 2x plus 3. And that would be your final answer. Okay, that's why we call them the long one. You have that extra step in the middle. You don't have to do that when there's a 1 in front of the x squared. Okay? So let's get rid of 13 and 14. I'll leave you 2 of those to do. Okay? And these are super quick. These are everyone's favorite. These are called difference of 2 squares. Difference of squares, let's just say that. Guys, the word difference means subtraction. So there'll always be a subtraction sign. And squares means everything is a perfect square. Remember your perfect squares, 1 times 1 and 2 times 2 and so on. So 1, 4, 9, 16, 25, 36, and so on. And letters are perfect squares if they have a even number exponent. So x to the second, the square root of x squared is just x. The square root of y squared is y. And these are super fast. We make 2 parentheses with 2 different signs. There's always going to be a positive and a negative. Same thing here. 2 parentheses, 2 different signs. And then you just do the square root. So the square root of x squared, like I said, is x. We put 1 in the front of each set of parentheses because it's the front of the binomial. And then the square root of 1 in the back. Done. Yeah. Square root of 16x squared is 4x. That goes in the front of both. The square root of 100y squared would be 10y. That's actually a bad example, but we'll talk about it. All right, so that will be 15 through 18. So I put my notes right in line with the problems that go with them. But you should be able to recognize them, all right? So cut 13 and 14. Let me start with you. Yep. All right, let me start with you. Okay, remember, these are the GCF problems, but start recognizing them. You know, when you get into the work in Chapter 9, it's not going to be laid out like this. They're going to be all mixed together. So start saying, okay, I can tell that these are GCF problems by the way they look. Okay, so I can factor out a 6, and you're just dividing these by 6. That's it, the answer. You doing? Okay. 9 and 27, I should have said about 6. 6 and 36 have a 2 in common, a 3 in common, but we always take the biggest number, okay? 9 and 27 have a 3 in common, but they also have 9. We want the greatest. G stands for greatest, the biggest number that they have in common. How many p's can I take? 1. Excuse me. And what's left over? P minus 3. Okay, now I'm going to put the key up, which is nice and neat and pretty. I showed all the work. I did say you could cut 30. So you can cut 13 and 14. I'm not going to cross them out on mine in case somebody wants to practice with them. I did show the work, okay? I'm just trying to cut back on your work a little bit here. Uh-huh. Okay. Yep.